All right, 1-5 warm up. Let's focus, people. All right, so on this one it says given f of x is 3x minus 1, g of x is x squared minus 4. Find the following and include domain restrictions. So remember for things adding, subtracting, multiplying, and dividing like 1, 2, 3, that when we talk about our domain restrictions, you have to check both original ones and carry down both original ones if there's a restriction, and then check the new one. So before we even get into the rest of it, we're going to check our original functions for domain restrictions. Is there one on the f of x? No. If there was, I'd carry it down to everything that used f of x, 1, 2, and 3. How about g of x? Domain restriction? No. So I don't have to carry down either. Again, if either of them had a domain restriction for adding, subtracting, multiplying, and dividing, I'd have to include both. Okay? It changed for composite. We'll get to that in a second. So I'm just adding the f and the g, 3x minus 1 plus x squared minus 4, and then you want to combine your like terms. And you can leave it just like that for your combined function. Then you want to see, is there any new restrictions? Are there? No. So the domain of the whole thing is negative infinity to positive infinity. Then I go to 2. I'm subtracting. So 3x minus 1 minus x squared minus 4. And that negative goes to both. So 3x minus 1 minus x squared plus 4. And I get negative x squared plus 3x plus 3. Checking that for new restrictions. Do they exist? No. So my domain is all real numbers again. Questions on that one? All right, then I go to 3. Now I'm putting f over g. So 3x minus 1 over x squared minus 4. Nothing carries down. Did I introduce a new restriction? Yes. What is it? This cannot equal 0. So x cannot equal negative 2 or positive 2. So my domain is negative infinity to negative 2, negative 2 to 2, and 2 to positive infinity. Yes.
When you do the thing that you have to like check, like negative 2, and you have to put 0.
That's if that was in a square root. So if it was square root of x squared minus 4, and you've got an inequality. Okay. So because it, well, not and you have, because it had a square root, you would bring in the inequality like greater than or equal to 0 or greater than 0 if it's in the denominator, and then you test points. So it's the quadratic, so x squared or x to the third, anything higher than x to the first, and an inequality is when that happens. The test points happen.
Is it also like when there's a square root and it doesn't matter if it's in the numerator?
You would need it for both because in the numerator it's or equal to, in the bottom it's just greater than. But if it was quadratic, you'd have to do both. Okay, then comes the composite. So the rule on the composite domain is we carry down the 1 for the function on the right. So if there was a domain restriction on g, I would have to carry it down, not f, just g. There's not, so I don't have to worry about it. And then for 5, if there was a domain restriction on f, I'd have to carry it down. There's not, so I don't have to worry about carrying anything down. Then I would actually see, if I took g and I plugged it into f for the first one, would I be introducing a new restriction? No, there's no square root, there's no denominator, which means the domain of this would have been all real numbers. Then I can actually do the process. So I'm going to take negative 1 and plug it into g. And I get negative 1 squared minus 4, 1 minus 4, which is negative 3. And then I want to find f of negative 3. So I do 3 times negative 3 minus 1, negative 9 minus 1, which is negative 10. So the value at the end is my answer. Remember, it's not like two parts. I don't keep both. Now I want to repeat that for 5. Again, we said f doesn't have a restriction, so we don't have to worry about bringing it from the top. But then if I took f and I plugged it into g, I'm just raising it to the second power. I'm not introducing a new restriction, so I don't have to worry about either of those. The domain would be negative infinity to positive infinity. And then I'm going to find f of negative 2. So I take negative 2 and I plug it into f. And then I find g of negative 7. So negative 7 squared minus 4. 49 minus 4, which is 45. It usually does not ask you for the domain restrictions when you have an actual value in the place of the x, like 4 and 5, but I did want to discuss to remind you that you have to check If it was like an X, you have to check the one you're plugging into the other one, so the one on the right. Questions? Any questions from the homework either? Okay, so we didn't go over it on the warm-up, but on the homework you had the questions that had the graphs with the combined functions. That's going to happen on your test, okay? It's on the review, but just as a reminder, that will also be there.
For the combined functions, we have to graph them?
No.
Okay.
It's going to give you the graph, and then you got to pull the answer from the graph.
Okay, thank you.
You're welcome. All right, so we're going to go through this, okay? This is a loose overview of all the things that you need to know for your test, starting with C1 through 1-5. Yeah.
For the graph one on the homework, if it's gonna be on the test, do we have to find the equation for the graph?
There is ones that you have to find the equation of the graph, but not with, not a composite graph, just one of those graphs.
Oh, okay.
And it will be one, so you'll be able to figure out from what you know from 1-4, based on transformations, you'd be able to do it. Yeah. All right, so this is the stuff that was on your quiz. C1, distance formula, midpoint. C2, graphs of intercept, symmetry, and then the circle stuff. So to go way back, and I made it a note for you guys so you can move things around. Like, if you don't like my handwriting, change it. But the idea is hopefully you don't have to rewrite everything because it'll take a long time.
Oh, you have it?
Yeah, it's on the module. So distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared, okay? And it's not going to be a straight up question like what's the distance between these 2 points. It's more of application when you get to like the circle one. This has to be a simplified square root. So if I had something like square root 20 as an answer, you'd have to change that to 2 root 5. Then you had midpoint, so x1 plus x2 over 2 and y1 plus y2 over 2. This time it stays as a coordinate point. Then comes your intercept. So for the x-intercept, we plug 0 in for y. For the y-intercept, we plug 0 in for x. We solve. There's some usually factoring involved there. And those are given in coordinate point form. So it would say a number, comma 0, or 0, comma a number. Then came your symmetry. So for x-axis symmetry, we change y to negative y. For y-axis symmetry, we change x to negative x. And for origin, we change both x to negative x and y to negative y. And then we check if it simplifies to the original or every term changes sign on both sides of the equal side, then it would pass whatever that test was. So if it was when we changed the y to negative y, we would say it has x-axis symmetry. X to negative x, y-axis, and then both would be origin. Then came finding the equation of the circle given the endpoints. So we did these with the center and a point, and we did them with the 2 endpoints. Your quiz had the one with the 2 endpoints. The standard equation for a circle is x minus h squared plus y minus k squared equals r squared. So if you were given the endpoints of the circle, what's the first thing you have to find? Before the midpoint, which doubles as? What is the midpoint? Good, the center. So midpoint or center is what we're going to find first. So 5 plus 7 over 2, negative 3 plus 1 over 2, 12 over 2, negative 2 over 2, and I get 6, negative 1. And that's the center, so that's your H and your K. And then we said there's 3 ways really to do the next step. One is find the distance from the endpoint to the endpoint and cut it in half. And I said don't do that because if you get a square root, people make mistakes when they try to cut square roots in half. Sadly, it happened on the quiz. So listen to me this time. Don't do that, okay? The other option is to either, once you find the center, find the distance from the center to one of the endpoints. That's still your R. So when you plug it back in, you have to square it, which is fine, only one more step. But still, I would say the easiest way to do it is take and plug in the center and one of the coordinate points. And I would say if there's one without a negative, choose that one because we make less mistakes. So this is my X and this is my Y and this is my H and this is my K. And I plug it in. So 7 minus 6 squared plus 1 minus a negative 1 become plus 1 squared equals R squared. And I get 1 squared plus 2 squared, or 1 plus 4. And R squared is 5. Then all you have to do is plug back in the H, the K, and the R squared. X minus 6 squared plus Y minus a negative 1 becomes plus 1 squared equals 5. Questions so far? So all that stuff was on your quiz. Hi, sunshine. Okay, then came 1-1, which was the graphs of linear equations. So there was 3 different equations you can use in this section, which is slope, intercept point, slope, and standard. If you can get that little highlight box in the middle to go straight, have at it. I tried. It wouldn't. It drives me crazy, but I couldn't get it that day, and I gave up. Okay? But the slope intercept is y equals mx plus b. This is our default end format if it doesn't say otherwise. Point slope, y minus y1 equals m times x minus x1. That we can plug into. It might ask you to put it in point slope at the end, but that's rare. And then standard ax plus by equals c. No decimals. No fractions. And x must be positive. Again, it might ask you to put your equation in that format at the end. If it doesn't, you default to slope intercept. We went over that slope is y2 minus y1 over x2 minus x1, or the variable of m. And that we talked about that from our standard form, the shortcut is negative a over b. So that helps save time. Like obviously anytime there's a shortcut, it's going to help you save time.
And that's what? That's how you find your slope?
If you have an equation in standard form. So like the example on the bottom, that one's in standard form. What's true about two lines that are parallel? What's true about their slopes? Same slope. How about perpendicular? Good. Opposite reciprocal. So flip your sign. Flip your fraction, change your sign. I actually only think there's one question from this section, and it's something like the one on the bottom where it puts the two together. Oh, no, there's 2. But this one puts the 2 together, okay? You're going to find the equation of a line that passes through the point, negative 5, 4. That is A parallel, B perpendicular to a line with the equation 7x plus 2y equals 8.
So this is how the question is.
Yep. So the first one we're going to do is when it's parallel. The second we're going to do when it's perpendicular. Before we get to either of those, we got to figure out what the slope of the original line is. So this is in standard form. So the slope would be what?
-7/2.
Good. If you don't use the shortcut, you got to solve for y. It's going to take you a little bit longer. But if you are shaky on it or you forget, then obviously go back to your y equals mx plus b form because that's 100% going to work. So now if it's parallel to that, what's the slope? -7/2, and I'm using the coordinate point -5, 4. And then when I go to answer B, my slope is the opposite reciprocal, so 2/7, same coordinate point, negative 5, 4. When I taught you this, I said you can choose between either plugging into the y equals mx plus b format or the point slope. Same is true for your test. I don't care which format you use, okay? But because it doesn't tell you to put it in a standard, you want to make sure your answer at the end is in slope intercept. So I'm going to plug in. I'll do the first one, point slope, and then I'll go to slope intercept. So y, this is my x1, y1. Y minus y1 equals m times x minus a negative 5 becomes plus 5. Distribute y minus 4 equals negative 7 halves x minus 35 halves. And then add the 4. That 4 becomes 8 halves. And negative 35 plus 8 would be negative 27 all over 2. Now, when you compare your answer to the original equation, it should have the same slope. Obviously, a different b, but the same slope. All right, and then b is perpendicular, so the slope's now 2/7. Your coordinate point is negative 5, 4. So I'm going to do y equals mx plus b. This is my x, and this is my y. So 4 equals m, which is 2/7, x, negative 5, plus b, negative 10/7 plus b, and then add the 10/7. Four over 1 is the same thing as 28 over 7, and I get 38/7 equals b. And then I take and plug back in the m, which is 2/7, and the b, 38/7. Don't waste your time putting that into a mixed number, okay? Keep it in proper. It has to be simplified, but keep it in proper. Otherwise, you're wasting time. I would say if you know what you're doing, you're going to be fine. If you have to try to teach yourself what you're doing while you're going, or you're struggling with your graph and calculator part, this is going to be a time-aggressive test. There's just a lot of content, okay? If you know what you're doing, no problem. But if you're like, I don't remember how to do this, so you're trying to figure it out, move on and go back to it.
I'll give you a point slope for.
I just said you could do either one. Yep, you could do either one, so you get to choose. All right, from this section was your linear equation word problems, where it's going to give you words. You're going to figure out a linear equation and then answer a question based on it. So that was in the homework from WebAssign in 1-1, if you want to go back. And I'm not going to give you an exact example because they're all going to be different, but yeah.
During the test, will I have to put it into the standard?
No, unless it tells you otherwise. Yep.
Can I charge my iPhone?
Sure. You haven't. You can pull it. You can just pull that desk right over. All right, then came 1-2, which is your function. So we started by identifying if it's a function from an equation. We actually started with coordinate points, but we said that the same x can't repeat with a different y. From an equation, yeah.
Yeah, I have a question.
So if y is raised to the even power or an absolute value, it's going to fail your vertical line test, which is why the graph is there. But you should be able to tell from your equation that that's a no. Okay. Other than that, they're going to be functions. We also had the piecewise function. Now in 1-2, you evaluated them. In 1-3, you graphed them. I just put it together here because it's going to do the same for your test. It's going to give you one piecewise function, and it's going to ask you to evaluate, and then it's going to ask you to graph it. So to evaluate, the first thing we need to do is figure out which of the ranges the x is. So because it's saying f of 0, and 0 is in between -2 and 1, I'm going to plug it into x plus 1. And 0 plus 1 is 1. And then, because 3 is greater than 1, I would plug that into the bottom one. 3 squared minus 1, or 9 minus 1, which is 8. These are your time savers, right? That should take you less than 30 seconds to do those. Then you have to graph it. So I'll change the color here so we can kind of see it visually. But let's start with the first one. Remember we said that there's two ways to do this. Graph what's there, or graph the whole thing, and then erase it based on its range, or plug in points. So if I did the whole line, because that's a y equals 3x minus 1, I'd start at 0. I'm going to start at -1. And I'd go up 3 and to the right 1. And I'd draw or down 3 and to the left 1. and I draw the line. And then I only want this to stay where it is for where x is less than 2, negative 2, which means I'd actually have to keep going 2, 3, negative 2. And that would be where my open dot is. So down 3 to the right one, down 3 to the right one. My open dot would be here. And if I did it again, down 3 and to the left one, not right one, I don't know why I'm saying right. That's where my line would take me. The other way to have found that is plug in points. If I had plugged in negative 2, I would have gotten negative 7. That's where that point comes from. And then if I had plugged in negative 3, I would have gotten negative 10, and that's where that point comes from. You get to choose how you do that. Then from negative 2 to positive 1, my equation is x plus 1. So if I started at positive 1, because that's where my y-intercept is, and my slope is 1, I'm going from negative 2, and this time it's a solid dot, to positive 1, and this time it's a solid dot. So my line there would look like that. Again, you could also have plugged in negative 2 and plugged in 1 and then connected them. And then the last one is a parabola. What's the transformation on the parabola if it's x squared minus 1?
Down.
Good. So you can either go down 1, plot your point, go up and out 1, and then I need to go till where it's positive 1, so really it starts there. If I go to 2 and I plug it in, I'd get 4 minus 1, which is 3. And then I know my curve is going like this on the right. It would go like that on the left. But I only want it where it's greater than 1. So I would erase all of that, and I would make it an open dot on 1. You could have also plugged in points. I would have started with 1, and then gone to 2, and then finished with my arrow. Questions on that one? So again, the evaluate part was in 1-2, the graph part was in 1-3. You're going to do this by hand, so you're not going to graph that with your graphing utility. If we were to do that, we'll have more practice on the piecewise stuff. Question? Do you have one?
No,
Okay, well, you're looking at me like you might have a question.
a little question.
Oh, I knew it. See? Okay, then came domain from an equation, which we've practiced a lot since then. All right, so the domain, we've done a lot of practice with this, so hopefully you're okay with this, but it's from an equation. It is all real numbers, that's what that R means, or negative infinity to positive infinity, except if the variable's in the denominator, we set it not equal to 0. Under the square root, set it greater than or equal to 0. Under the root, in the denominator, it's greater than 0, and you're gonna write it in interval notation. Remember, if 2 restrictions occur, you have to find where the overlap is. So if there's more than one restriction in your function, you can only keep where it overlaps, where they would both be true. Okay, then we did difference quotient. Wait for it. Oh, bastard. It is f of x plus h minus f of x all over h. This is one of those questions that the more you practice it, the better it's going to be, because by the time your test rolls around, if you've done it a few times, you probably have your x plus h squared memorized. Like, that kind of thing is going to help you with time. You could do it. And then everything under that is your graphing calculator question. So that 1-3 with domain, range, increasing, decreasing, all that stuff is actually going to come first. I'm feeling this jumped off Wi-Fi. So all of this, which technically is one numbered question, but the points are broken down. I think it ended up being like something like 24 points or something like that. But it's like 2 points a line. So like 2 points for domain, 2 points for range, 2 points for increasing, decreasing, whatever it is like that, okay? Remember, domain and range is in interval notation, left to right, and then range bottom to top. Your increasing, decreasing constant behavior is your x values on those intervals. So before you even answer that, you're gonna have to go to your max and mins. That's where it changes direction. So I'm gonna give you a little graph for you to draw just as your own reference so that you can kind of label your points. I would label your max and mins, and then that's where you know it changes direction. Yeah.
This is all the graph, right?
This is all your graph and all with your calculator.
Mm-hmm.
Yeah. The zeros, you are going to list them for me. I just want the x values. These are not in coordinate point form. Your max and min, those are in your coordinate point form. And then your even and odd from your graph, you're just looking to see if they're symmetric. Even would be to the y-axis. Odd is origin. Okay, think O, right? O and odd. And then the value, all of that, where you go second calc, you go to your value menu and you plug in your point, okay? Don't allow the calculator to frustrate you. Like, the more comfortable you are with your calculator, the easier this section should be, okay? There is a practice that's just a calculator question that I put on your assignment, like that's separate PDF that's just the calculator question. And then there's also another practice on the PDF that has all of it. So do as much as you need. Well, hello, sir. We will start with the graphing calculator portion, which means from the moment you walk in the classroom on Thursday, we are getting started. You're walking in. The covers are already off your calculator because you know I'm going to ask you anyways. When I tell you to reset, you're going to hit reset so we can get this started quickly. I'm going to come around and check. And then you're going to start with the graphing calculator portion. When you're finished, the calculator goes on the ground. The rest of the test gets finished. And then that way, if you need to go back, you can go back. But I would say this total question, like as many parts as that, if it takes longer than 5 minutes, you're taking away from the rest of the test, okay? And that the only way that should happen is if you don't know what you're doing on your calculator. So you've got 48 hours to make sure that that is not an issue. Yeah.
Does it matter if your calculator is in reading?
No, that only matters when we hit sine and cosine and tangent, which we won't do. Yeah.
How many questions like around like are there?
So I think there's only 8 total questions, but this is
A
one.
bunch of parts.
Yeah. So I didn't count how many blanks. I told them I would count how many blanks and let them know tomorrow. I'll do the same for you guys. But yeah, but I think the 8 or 9. But that's really not a good depiction of how many. Yeah. All right, then 1-4 is your transformation. So there are 2 questions like this with multiple parts within, but 2 questions where it's going to ask you for the parent function, it's going to ask you to describe the transformations, and it's going to ask you to graph, okay? So remember your overall parent functions, x squared, absolute value, square root, x cubed, and reciprocal function. And then I only put a squared one on there, but we're going to talk about all the different parts. The plus or minus on the front does what? The plus or minus all the way to the front. Reflection over the x. Good. It looks like it's upside down, right? But the official terminology is reflection over the x. The a, so the thing on the front of your function, if it is greater than 1, it causes what? Vertical. A vertical stretch. By a factor of a. Whatever that value is. If it's in between 0 and 1, what happens? Good. Vertical compression, again, by a factor of a. Yeah.
Will we have horizontal?
I'm going to put it on there. Yeah. If there's a value in front of the x, this causes your horizontal compression or stretch. So if it is greater than 1, it causes a compression. Remember, it's the opposite. Horizontal. I shouldn't call it A. I actually think it's C on the grand scheme of things. I think that's what we put on the thing. Horizontal compression. But it looks like a stretch because if the walls caved in, it would even make it more narrow. And if it was in between 0 and 1, then it's a horizontal stretch. Like it's being pulled from the sides by a factor of C. Edward.
Why is the horizontal stretch and compression not
because it's on, so on the front of the function is vertical stretch and shrink. Inside the parentheses or inside the absolute value or inside the square root with the function, that's a stretch, of a horizontal stretch or compression. So they're two different ones. A lot of times they look the same. Remember we did this with like the squared. A horizontal compression looks a lot like a vertical shrink. All right, then the H. If you add, it goes left. If you subtract, it goes right. And B at the end is your vertical translation. If you add, it goes up. If you subtract, it goes down. And then finding the equation from a graph. So the reverse of this. You'd have to look at a graph and give me the equation. So this is right 2, up 1, minus 2, plus 1. So it would look like that. There will be no stretch or shrink on those. They'd only be non-grid, but it could be a reflection, okay? Remember a negative square root reflection, that's the one that goes left or over the y. That's really the only one that you'd see like that. The last slide is your 1-5, which we talked about already. So my advice is that you make sure that you take care of everything. I would do as much of the review as you can tonight so you have questions tomorrow. But you do not need to do the whole thing. There's a lot of examples. Have a great day.